Since even functions are not one-to-one, it doesn't pass it's not one-to-one. It does not pass the horizontal line test. Their inverses are not functions. However, with restrictions on the domain, an inverse can be found. I can restrict the domain. I am going to restrict the domain, and I would like to find the inverse of from 0 to infinity. I want to find the inverse on this part of the function. I am going to restrict the domain from 0 to positive infinity. It includes 0 going to positive infinity. I can find the inverse of that part of the function. I would like to see my y equals x line. One. When x is 2, y is 2. When x is 3, y is 3. Here is the line that I would like to use to help me find the inverse. Usually, we just make a dotted line. Graphically, to find the inverse, I am going to use 2, 4, 1, and 0, 0. If 2, 4 is on the function, then 4, 2 would be in the inverse. This is on the line. It'll be in both the functions, and here is 0 that I'm using. This is going out and then crosses the line. I would be going out and then crossing the line. This is the inverse function. F of x and f inverse of x. That is doing it graphically. If I was looking at the equation, I need to switch my x and y values. Well, f of x equals y, so I have y equals x squared. How do I find the inverse? I switch my x and y values. I have x equals y squared. I am restricting the domain from 0 to infinity. Now I need to solve for y. If y is being squared, what is the opposite of squaring? Square root. Square root. I don't need the negative. It's not plus or minus because I'm going all the positives. We have that y equals the square root of x. Y inverse equals the square root of x, or f inverse of x equals the square root of x. F inverse of x equals the square root of x. Find the inverse of f of x equals x squared plus 4. If the inverse is not a function, then restrict the domain so that it becomes 1. This is a quadratic. The quadratic at the origin, 0, 0, 1, 1, negative 1, 1. This quadratic is being shifted not on the x minus h squared plus k. It's not being shifted on the x, it's being shifted up 4 units on k. My center here would be 0 for x, 4 for y. That is where the vertex is, 0, 4. I could do a table of values. When x is 1, 1 squared is 1 plus 4 is 5. When x is 2, 2 squared is 4. 2 squared plus 4. that would be 8. At 2, we get 8. Just looking for some guiding values. At negative 2, negative 2 squared plus 4 is the same thing. Negative 2 squared is 4, and 4 plus 4 is 8. At negative 2, we're also at 8. Some guiding points here. Again, this is not going to pass the horizontal line test, so I'm going to restrict it. Now, you don't always have to restrict this side. I could have done this side over here, which is what I'm going to do this time. I'm going to pick the left-hand side of the parabola. We have the y equals x line. When x is 2, y is 2. When x is 4, y is 4. I like to have that guiding line here. We have the point, let's see, we have the point 0, 4, the point 2, 8. In the inverse, we would have 4, 0, and 8, 2. If I look at this, I'm on the axis, I'm on the y-axis. That means in the inverse, I would be on the x-axis. I am going out. I would be doing the same here. I'm going out. This is the inverse function here. Y equals x squared plus 4, y inverse. Let us find the inverse of the function. Y equals x squared plus 4, switch your variables, x equals y squared plus 4. I see I need to undo addition and the exponent. Subtract 4 to both sides. What undoes a square? A square root. Y equals the square root of x minus 4. This is a square root function. I will finish by notating that it's the inverse. Y inverse equals the square root of x minus 4. This is a square root function. Notice that the square root function normally starts at 0, but here our x value has been shifted to positive 4. It is starting at positive 4 and going to infinity. Example 5, find the inverse of this function. Y equals negative square root of x minus 4. Switch your variables. X equals the negative square root of y minus 4. I'm going to start by getting rid of my negative. If I multiply this side by a negative and multiply this side by a negative, we have negative x equals the square root of y minus 4. I'm solving for y. I can't undo the subtraction because it's in the radicand. I need to undo the radicand. What is the opposite of square rooting? That would be squaring. Negative x times negative x is x squared equals y minus 4. A square and a square root undo each other. Finish by adding 4 to both sides. And we find that y equals x squared plus 4. Y inverse equals x squared plus 4. We started this time with the function being the square root, and we found the inverse ended up being the square. We just did the opposite of starting on the example 4. We started with a square and we ended up with a square root. On example 5, we started with the square root and ended up with the square. They are inverses of each other.